So we're going to be continuing the notes on this video because my other one got cut off. But our next theorem is AAS, which means angle, angle, side. And it states that if two angles and the non-included side of one triangle are congruent to two angles and the non-included side of another triangle, then the triangles are congruent. So basically what we have is, first, we are given that angle C is congruent to angle F, angle B is congruent to angle E, and that side AB is congruent to side DE. So since we have the non-included side, AB and DE, we have to use AAS for this instead of angle, side, angle, or ASA. So since we do have those things, we can conclude that triangle ABC is congruent to triangle DEF. Now, the CPCTC thing means that once I've said that triangles are congruent, then I can conclude that all of their other corresponding parts are congruent. So I can say that angle A is congruent to angle D. I can say that side AC is congruent to side DC, and I can say that side CB is congruent to side FE. So those are all the other parts that we did not use to prove the triangles, but once we know the triangles are congruent themselves, we can conclude those parts are congruent. Now, the last theorem that we're going to go over is HL, or hypotenuse leg. And this will only work with right triangles, but basically it says that if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So we have to know that the triangles are right triangles, plus those are the only triangles that have sides that we name hypotenuse and leg. So once we know the triangles are right triangles, we have AB is congruent to XZ, which is the hypotenuse, and then we have AC is congruent to ZY, which is one of the legs. So by HL, we have that ABC is congruent to XYZ. Now this is actually another version of SSS, because once I know that the hypotenuse and leg are congruent in both triangles, I can always find the third side of a right triangle using Pythagorean theorem. So I know that if I plug the same numbers into the same spot of Pythagorean theorem, because I know the hypotenuse and leg are congruent, I'm going to get the same answer for the other leg. So really, I would know that if I know hypotenuse and leg are the same, because right triangles have this special relationship, I automatically know that the third side is going to be congruent as well. So that is why this is another version of SSS. If you look at the triangle, just ignoring the third side, the way that the right angle and the sides are placed is in the SSA format, which we know is not a reliable source. That's the purple triangle that we did in the group activity. And so it's not another version of SSA, it's actually another version of SSS. So finally, I want you to remember that AAA and SSA are not reliable ways to show triangles are congruent. Basically, AAA, if you look at the orange triangles that we did in class, they're all dilations of each other. And SSA, just a way that you could remember that it's not a reliable way, is if you move the A in front, it spells something, and we probably wouldn't use that for an acronym for geometry. So that's a way that it could help you remember that that's not a reliable way. So last, I want you to look at these two triangles and think about which theorem can be used to prove the two triangles are congruent. And once you come up with a theorem, I would like you to write a congruence statement. So you're going to match up the parts in the right order and say the two names of the triangles, and that they're congruent, and make sure that the corresponding parts are in the correct order.